Okay, so what we're going to be talking about today is functions and graphs. So you should be open to 1.2 on your calculator and be ready to go. Okay, so by the end of this lesson, you will be able to determine whether a correspondence or a relation is a function, find function values or outputs using a formula or a graph, graph functions, determine whether a graph is that of a function, and solve applied problems using functions. All right, so a function is considered a correspondence between a first set, which we call the domain, and a second set, which we call the range, such that each member of the domain corresponds to exactly one member of the range. Okay. On the following two pages, we're going to determine if each relation is a function or not. All right, so -6 and 6. -6 and 6. And remember, we're looking, so each member of the domain corresponds to only one member of the range, meaning your x values are not going to repeat. So this first one is a function. And again, every member of the domain only corresponds to one member of the range. So yes, this is also a function. Okay. Appointing president, Supreme Court justice. So each member of the domain can only go to one member of the range, your domain being the presidents, and your range being the Supreme Court justices. So if you're looking here, we've got George H.W. Bush going to one member of our range, Bill Clinton going to 2, George W. Bush goes to 2, as does Barack Obama, which means this is not a function because our members of our domain are traveling to more than one members of our range. Okay. Okay. Here we're going to determine whether each of the following is a function. Same thing. What you see in blue is your domain. Red is your correspondence or your relationship. And range is in black. First one says years in which a presidential election occurs. The person elected is your correspondence, and the set of presidents is your range. And this correspondence is a function because each presidential election gets exactly one president elected. Okay, so only one president is being elected in the year for a presidential election. So that first one is a yes. All automobiles produced in 2012, each automobile's VIN number, so that is your correspondence, and a set of VIN numbers is going to be your range. This correspondence is also a function because each automobile has exactly one VIN number. Okay, they don't make the same VIN number for multiple vehicles. It goes from one car to one VIN number. So that's a yes. C, set of all drivers who won a NASCAR race in 2011. The race won is your correspondence, and the set of all NASCAR racers races in 2011. This one's not a function because a winning driver can be paired with more than one race. Okay? Dale Earnhardt Jr. won more than one race. So he'd be paired to more than one. All right, the set of all NASCAR races in 2011, the winner of the race, and the set of all drivers who won a NASCAR race in 2011. This is a function because each race only has one winning driver. Okay? So that's just how we put it into words, and you do kind of need to get used to that setup. All right, so a relation is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to at least one member of the range. Okay, so it just makes a relation. Determine whether the following relation is a function. Identify the domain and range. Now guys, this should all be reviewed, so we're going to go through this pretty quick. Your domain is going to be the values 9 and 2, 9, 9, and 2. Okay. Range is going to be -5, 5, and 4. And remember, with a function, you can't have any repeating x values. So this is not a function. No repeating x values for functions. Okay? No repeating x values. All right, so same thing here. Domain, -2, 5, 0, 4. Range, 5, 7, 1, -2. Since we don't have any x values that repeat, this is a function. All right, next page. Same thing here. Let's just look at those x values. This is a function. Okay. Even though they all go to the same element in the range, only one member of the domain goes to one member of the range. So it is a function. Okay. I think you got domain and range for that by now. Okay, so a function f is given by f of x equals 2x squared minus x plus 3. We want to find f of 0. So all this is substitution, right? We know how to evaluate these expressions. We've done it a million times. So f of 0 equals, everywhere you see an x now, you're going to replace with a 0. 2 times 0 squared minus 0 plus 3. Order of operations tells us we should start with exponents first. 0 squared is 0. Then multiplication. 2 times 0 is 0. And then addition. 0 minus 0 is 0, plus 3 is 3. Hopefully this should be no problem at all for you guys. Next page. Okay, so we're going to do the same thing here. F of -7 Okay, exponents first. -7 squared is 49, minus a -7, which we could just go to 7. Multiplication next. Notice I'm bringing down that f of -7 each time. 98. And then f of -7 is 108. Okay. Let's get a little bit more difficult. F of 5a. So instead of plugging in just a constant, we are now plugging in a variable. So same thing, it's just substitution into the location where the x was. And then we do the math that goes along with it. So that exponent first, 5a squared. Remember, you have to square everything in there. 25a squared. Multiplication next. 50a squared minus 5a plus 3. And since the rest of that has no like terms, that would be your answer. All right, let's try this. F of x minus 4, or I'm sorry, f of a minus 4, my apologies. So we substitute in. Now don't forget what this quantity squared means, okay? That means that you have to actually go through and FOIL that out. All right? So we're going to keep our 2. A squared minus 4a minus 4a is minus 8a plus 16. Okay. I'm going to distribute through 2a squared minus 16a plus 32. I'm going to distribute through that negative sign, minus a plus 4 plus 3. Now I'm going to go through and combine like terms. I don't have any other squares, so I have my 2a squared to begin. Negative 16a minus a is negative 17a. Plus 32 plus 4 plus 3 is plus 39. And there it is. Okay? Go ahead and move on to the next. All right, so graph the function f of x equals x squared minus 6 and use the graph to find the value of f of negative 3 and f of 1. So the first thing we're going to do is we're going to go down here, we're going to graph this. Now, we know it's a quadratic, so we know we're going to be looking for a parabola. To bring up that function line, you're going to hit Control G. Okay. We're going to graph our function, x squared minus 6, and we get this. Now, there's a couple ways we could do this. We could utilize the table to determine what f of negative 3 is and f of 1, or we could use our point on tool or trace. Now, I find that the easiest way to do this is to deal with that table. Okay? So Control T is going to pull up that table for you. And the values of x are right here. So as we go down, 1, 2, 3, 4, 5, 6, 7. So we want the values of f of negative 3. So f of negative 3 is going to be 3. Okay, right? F of negative 3, there's the x value, and then its output, or our input, right? Input, output is going to be 3. And then f of 1 is going to be negative 5. So that means on this graph, these points exist. They're solutions to that equation. Okay, next page. Vertical line test. Okay, so a vertical line test, basically what it does is it tells us whether or not a graph is a function. So if you can pass a vertical line through a graph without touching the graph in more than one location, then the graph is a function. Okay? So let's take a peek. All the ones that you see here are not functions, and the reason being is when I pass this vertical line through, it touches the graph in 2 locations. Same thing here, not a function. Okay, same thing. We're passing in 3 locations here, not a function, and 2. Okay, so anytime it passes more than once, it's not a function. All right, and with these are all functions because they're only passing through at most one time. Okay, so let's talk about finding the domain and the range. So the domain is understood to be the set of all inputs for which the expression is defined as a real number. So essentially what this means is a domain is going to be basically every single number except for the one that makes it undefined, or the ones that make it undefined. Okay? Undefined meaning doesn't exist. Okay, so for the indicated function values, if possible, determine whether the given values are in the domain of the function. All right, so f of 1 and f of 3. So we're going to find out, is it in the domain of the function? So what we're going to do is what we have been doing. We're going to start by substituting. F of 1 equals 1 over 1 minus 3. So f of 1 equals 1 over negative 2. Since we got a number back, we got negative 1/2, that is a member of its domain. Okay? So this one's a big yes. F of 3, 1 over 3 minus 3. So we get f of 3 equals 1 over 0, and we know that that is undefined. Okay? It does not exist. So this is not an element of the domain. 3 would not be an element of the domain for this function. Okay? And again, this shouldn't be anything new. Okay, so we're going to do the same thing here. Find the indicated function value if possible and determine whether the given values are in the domain of the function. G of 16 to start. Square root of 16 plus 5. So we get 4 plus 5. G of 16 is 9. So that gives us a value, and that is part of the domain. G of negative 7. Square root of negative 7 plus 5. Okay. We know that you can't have a negative in a radical. So this does not exist. So negative square root of 7, or negative 7 would not be an element in the domain of the square root of x plus 5. All right, so how do we go about finding just the domain? Well, that part's pretty easy. We want to think about what makes this function, what would make this function undefined, okay? That's really the only values that we're concerned about. So we know with fractions is we can't have a 0 in the denominator. That's what makes it undefined. So the way we find domain is by taking the denominator for fractions and setting it equal to 0. Solve for the x, and you have the value that x cannot equal, okay? So the way you would state that would be the domain equals all real numbers such that x does not equal 7. That's how you would express your domain. Okay. So let's try another one. Same thing here. We're looking for the domain. So you take that denominator, you set it equals 0. Solve. So in this case, you have two values. So your domain equals all real numbers such that x cannot equal negative 3 or 1. Okay? All right, so with absolute value, basically for absolute value, you can put any number that you want in for an absolute value. There's nothing that's going to make this function undefined. So our domain is going to be all real numbers, okay? Another way to express this would be from negative infinity to positive infinity. Okay, find the domain of the following function, the cube root of x minus 1. All right, so this is a special case. Because our index is odd, the radicand x minus 1 can be any number. So therefore, x can be any number. So the domain for this, again, is going to be all real numbers. Okay? Now, if the index were even, we'd be dealing with something different, because with even indexes, can't have a negative underneath that radical, so we wind up having to do something a little bit different. Okay, we're going to end here. This will be a 2-day lesson, so you'll finish the second half of this video tomorrow, and make sure that you come in with any questions, and I'll see you tomorrow. Thanks, guys.